press the bell icon on the YouTube app and never miss another update.
Hello dear students, so let me continue collisions from work energy power. Okay, now part 10 lecture from work energy power and collision is some second lecture I think. Okay, so anyhow in the last session I covered collision nothing but the strong interaction between the particles in which some momentum will be transferred in a small time interval of time, and you know during the collision bodies may be in physical contact with each other or may not be in physical contact with each other. Okay, and on the basis of direction of motion, collisions are classified into two types. One is one-dimensional collision, otherwise head-on collision, and another one is two-dimensional collision, otherwise we can call it as oblique collision. In one-dimensional collision, the particles are confined to only a single line, means before the collision, after the collision, the particles moves along a straight line. In two-dimensional collision, particles move in a plane. Anyhow, we are going to study two-dimensional collision also. So that is useful to solve some problems, especially in entrances, and that also I am going to cover in the continuation. And later, on the basis of total kinetic energy, we divided the collisions into two types. One is perfectly elastic collision, other one is inelastic collision. In case of perfectly elastic collision, there are two principles are valid. One is law of conservation of linear momentum, and other one is law of conservation of kinetic energy. And anyhow we know in that collision the shape and size of the particles does not changes after the collision. And the best example we given collision between atomic particles and the collision between nucleus and alpha particle. And in case of inelastic collision only law of conservation of linear momentum is valid but not the kinetic energy. Best example is collision between automobiles. Okay, during accident, collision between automobiles. And we know perfectly inelastic collision. In case of perfectly inelastic collision, after the collision, the two bodies stick together and they move with a common velocities. Okay, so the two bodies stick together, they move with a common velocities. Let us see what is that common velocity equation. Okay, so write down equation of common velocity. Otherwise let me continue some special cases, because last class I covered relative velocity of approach before the collision, which is equals to relative velocity of separation after the collision, and we calculated the velocities equation. Okay, velocities of the bodies after the collision, that is V1 we got, V2 we got. What is V1? I hope you remember the V1 V2 equations. Of course derivation is also very simple. I given V2 for you. I think you covered that V2. So V1 is m1 minus m2 by m1 plus m2 into u1 plus 2m2 u2 by m1 plus m2, and V2 is quite opposite, m2 minus m1 by m1 plus m2 into u2 plus 2m1 u1 by m1 plus m2. Okay, just check the previous equations. Now by using that equations, let me continue some special cases. Write down the heading special cases. So general things, special cases useful for some problems. Let us take case 1. If m1 is equals to m2, then let us see what are the v1 velocities, v2 velocities. Special cases in elastic collision. Anyhow we are in the elastic collisions only right now. Next we will enter into inelastic with some derivations. Okay, if two particles are having same masses, m1 is equal to m, m2 which is equal to m, moves with u1, moves with u2, and after the collision let us see what is v1, what is v2. Find v1 v2 value. I think you remember the v1 formula. Let me write v1 formula once at least. So what is V1 formula? M1 minus M2 by M1 plus M2 U1 plus 2 M2 U2 by M1 plus M2. Substitute M1 M2 as M. This is M minus M. M1 is M, equal masses. Okay, take this is equivalent to M, equal masses. M minus M 0. 2 M U2 by M plus M. So you will get 2M U2 by 2M. Then how much you are getting V1 value? Directly we can write. So how much V1? Velocity of the first particle after the collision, which is equal to what? Initial velocity of the second particle before collision. Velocity of the first particle after collision, which is equals to initial velocity of the second particle before collision. Okay, let us see V2. Okay, V2, what is V2 formula? Quite opposite formula, I think you remembered. M2 minus M1, U1 nothing but U2, M1 plus M2. This is 2 M1 U1. I hope you remember this formula. I think you got this derivation also. So M1 plus M2. What is V2? V2 is M minus M 0. 2. This is M U1 by 2M. So how much? I am getting V2 is equal to U1. That means what? From the two equations. V2 I got V1 is U2. V2 is U1. That means what? Velocities of the bodies are exchanges or not? If the bodies have equal masses, then the velocities of the bodies are exchanged. Okay, if the bodies have equal masses in elastic collision, then after the collision, the velocities of the bodies are exchanged. That means velocity of the first body after the collision, which is equals to initial velocity of the second body before collision, and velocity of the second body after the collision, which is equals to initial velocity of the first body before collision. That means velocities of the bodies are exchanged when both are having equal masses. So if two equal masses are collided elastically, so maintain a word, if two identical masses are collided elastically, elastically, then velocities of the masses are exchanges. Velocities of masses means bodies are exchanges. Simple thing, very simple. Okay. See one more case. Okay. Now see the next one. See the case number 2. If M1 is greater than M2 and M2 is rest. Okay. So not M2 0. M2 is at rest. Let us see what happened to the V1, V2. So find V1 value, V2 value. So I given condition m1 is much greater than m2 such that second particle is at rest. Then what is the final velocity of the first particle and what is the final velocity of the second particle? m1 is greater than m2 means a heavier particle hits a smaller particle. m1 greater than m2 means what? m1 is heavier, m2 is smaller. Heavier particle hits a smaller particle. And what about the smaller particle? That is at rest initially. Then after the collision, definitely the speed of the heavier particle and final smaller particle will something change. Let us see what are that v1 value, v2 value. v1 is the velocity of the particle, first particle after the collision. v2 is the velocity of the second particle after the collision. Now let us continue this. See, let us imagine like this. This is the heavier mass. This is going to hit a smaller mass. Yeah, smaller mass. And this is at rest, the given. Second body is at rest. m2 is at rest. It is moving with speed u1. Moving with speed u1. Then find it. As m1 greater than m2 and m2 is at rest, then which is very small? m2. So you can write m2 approximately negligible, you can take 0. Because comparing to m2 is very small, you neglect it. m2 is negligible. m1 is greater than m2 means m2 is very small particle. So neglect the m2. Then let us see what is v1. m1 minus m2 0. So m1 0 by m1 plus 0 into u1. m2 anyhow negligible. m2 negligible 0. So I got v1 is what? m1 cancel, only u1. Okay, let us check here. v2 m2 negligible. m2 is 0. Okay, m2 0 and m1 by m1 plus m2 0, but u2, what is u2? u2 also 0. u2 also 0 from the given case, condition. 2 m1 u1 by m1 plus m2 0. Then how much you are getting? v2 is equal to, this is 0, m1 2 u1, v2 is what? See, what is v1, what is v2? v1 is the velocity of the first particle after the collision. v2 is the velocity of the second particle after the collision. What about the velocity of the first particle after the collision? Does not changes. v1 is equal to u1. Means v1 u1 means after the collision also this body moves with the same speed in the same direction. If I got negative, that will move opposite direction. But what I am getting now? v1 is equal to u1. v1 is equal to u1 means first particle moves with the same speed after the collision. The speed of the first particle remains same. Before the collision, after the collision, it will be remain same. But see the second situation. v2. Initially the second particle is at rest, but after the collision v2, which is equal to 2 times of u1, means velocity of the second particle is double the initial velocity of the first particle. So second particle moves with a double speed of what? Second particle moves with a double velocity of first particle. Very simple. Heavier person hits a smaller person will move with a double speed. If I given u, it will move with 2u. I am moving with same speed. Okay, heavier mass hits a smaller mass. Heavier mass will move with the same speed because elastic. This is the elastic collision. If it is inelastic and some other collisions, maybe the speed of this one also changes. But this is a perfectly elastic collision. We are discussing perfectly elastic collision. Okay, perfectly elastic collision. So if it is moves with a u1 and due to this mass is negligible, then this will move with a double speed. So v2 is 2u1. For suppose if masses are same, just you see in a general thing, let us suppose they given like this. This is the one mass m moves with a speed v, and there are 3, 4 something masses are there. All are same. This is 1, 2, 3, 4. Tell me, if this is a perfectly elastic collision, let us suppose this is the perfectly elastic collision. If it is a perfectly elastic collision, if this particle hits this one, then tell me what is the speed of the 1, 2, 3, 4. Just you guess it. Simple thing. Because I am discussing perfectly elastic collision. If this particle hits the 1, 2, 3, 4, then what are the velocities of the 1, velocities of the 2, 3, 4? Can anyone guess? Simple question this is. Velocity of the 1, 0. Velocity of the 2, 0. 3, 0. Velocity of the 4 is v. Means this velocity is transferred to the last. Remaining all bodies will come to rest. If this will hit here, then this velocity transferred to this and this will come to rest. Got my point? If this particle hits these particles, then this velocity transferred to the one and this particle, left particle is there now, this will come to rest. And next this velocity transferred to the next, again it will come to rest. This particle velocity transferred to the next, again comes to rest. Finally the last particle will move with a speed. The last particle move with a speed v. Remaining all particles comes to rest because the collision is perfectly elastic collision. So velocity of the last particle is how much? V. Third 0, second 0, first 0. Don't expect one also V, second also V, third also V, fourth also V. No, because all are identical masses. Observe the conditions. All are identical masses. Here once this particle hits this one, then this particle comes to rest and this will attain a velocity v, and this is going to hit the next one, comes to rest, and that is going to hit the next one and comes to rest. Continuation. Finally the last particle moves with a speed v. So the answer in this case is 0, 0, 0 v. Okay, 0, 0, 0, last one is v. So this velocity is transferred, momentum transferred, nothing but collision. Okay, in a small time interval. Okay, and see one more condition here. Let us see the reverse condition. Completed this. Do the reverse. If reverse m2 greater than m1 and m2 is at rest. Write the next case number 3. Simple things these are. Try the next one. m2 greater than m1 means what is negligible? m1 negligible. m1 is very small comparing to m2. Heavier particle hits a smaller particle. m2 greater than m1 and m2 is at rest. No, sorry, smaller particle hits the heavier particle because m2 is at rest. Okay, so m2 is at rest. Smaller particle is m1. This is m2, negligible mass, sorry, m2 is at rest, u2 0 and this is m1. What is m1? Yeah, this is the condition. Mass of m1 is small, so negligible. m1 you make it as a 0. Moving with the speed u1. Moving with speed u1 hits another mass whose mass is m2 and that is heavier than m1, but that is at rest. Indirectly, smaller particle hits the heavier particle, then what? What about the position of, what is the speed of velocity of m1 and velocity of m2? Just you substitute those conditions in a formula, you will get the answers directly. If a smaller particle hits the heavier particle, smaller particle will rebound. Means in answer you will get a negative sign. If you got the negative means correct answer. Okay. If a smaller particle hits the heavier particle, smaller particle definitely rebound. Heavier particle we don't know whether it will move or not, we will see. Okay, based on the mass. So V1 is M1. M1 is negligible 0 minus M2 by M1 negligible 0 M2. u1 and u2 anyhow 0, u2 0, second mass is at rest at given condition 0. M2 M2 cancel, minus into u1 minus u1. What is velocity of the first particle after the collision? It rebounds back with the same speed. If it moves with a 2 meter per second, it will come back with the same 2 meter per second in backward direction. Okay, come back with same speed, 2 meter per second. So v1 is equals to minus u1. What about v2? M2 is not 0. Minus m1 0. M1 0. M2, what is u2? 0. M1 0. Then what is the answer? So what is v2 here? What is v2? v2 0 means what? Is that second body, is the heavier mass will move? So there is a heavier mass. I think you know some spherical balls. Generally you will play in some playgrounds. If a smaller particle hits the heavier, what about the smaller particle? You will get rebate. Means the smaller particle will come back. Heavier will be stay there only. So speed of this one remains 0. That never move. Second particle is at rest. First particle moves with equal velocity in opposite direction. I am getting negative sign. Opposite direction. Okay. Okay, take this. Okay. See the next one. See the next thing. So next one also important concept. You feel all these are something note point used to solve some problems. So write down the heading. Fraction of kinetic energy and linear momentum in case of elastic collision. Right now we are in the elastic collisions only. Fraction of kinetic energy, linear momentum. Okay, next I will solve some problems based on V1, V2 formulas based on the given time. So let me continue this concept. After that, let me solve some easy level of questions. See the target. We have to find fraction of kinetic energy, fraction of linear momentum in case of elastic collision. So to find this, let me consider two particles whose masses are m1, m2. Okay, whose masses are m1, m2, and let us suppose m2 is at rest. So I want to get the fraction. Okay, how much kinetic energy will be transferred by one body to other body, how much momentum will be transferred by one body to other body, how much will be regained. So that I am going to get the fractions now. Okay, fractions I am going to get it now. See, so let me consider a particle of mass m1. Okay, a particle of mass m1 which moves with a speed u1 and hits another particle of mass m2 that is at rest. So this is before collision. First listen, then you write. So before collision, and this is the during collision, and after the collision m1 have speed v1, means attain velocity v1, m2 attains velocity v2. Yeah, see this. I consider two particles. One particle of mass m1 which moves with a speed u1, and that is hits the another particle of mass m2 that is at rest. And after the collision, v1, v2 are the velocities of the two particles. Okay, V1 is the velocity of the particle of mass m1, V2 is the velocity of the particle of mass m2. Okay, V1, V2. Target is to find a fraction. Anyhow, V1, V2 values are very clear. We know the previous equations. Okay, and see, before the collision, see this is after the collision. After the collision, before the collision, this particle have mass and velocity. So this particle have kinetic energy K instead of Ke. Okay, you write Ke. Kinetic energy Ke, and this particle have momentum P. What is Ke and P? What is Ke and P? Ke is the kinetic energy of the particle of mass m1 before collision. P is the momentum of mass m1 before collision. So Ke and P are the kinetic energies and momentum of the particle of mass m1 before collision. And observe after the collision this will have some kinetic energy, this will have some kinetic energy, of course momentum. Let us consider Ke1 and P1, and this is for what? Ke2, P2. What are these values? Tell me now. Ke1, Ke2, Ke1, Ke2 are the kinetic energies of the two particles of masses m1, m2 after the collision. After the collision, P1, P2 are the momentums of the two particles after the collision. P1 for m1, P2 for m2. Got this idea at least? See the way. Ke and P before the collisions. Ke1, P1 kinetic energy momentum of m1 after the collision. Ke2, P2 kinetic energy and momentum of m2 after the collision. See, I written here clearly. Now let us get the fraction. To get the fraction, let me continue here now. What is this Ke and what is this P? Ke, so before collision, Ke, how much Ke? Half m1 u1 square. Got it? Okay, let us take this is u, moves with u because there is no u2, so u is enough. U. Got this one? Ke is half m1 u square. Okay, coming to the momentum. What is the momentum? m1 u momentum. So Ke and momentums are completed. After the collision, kinetic energy Ke1 half m1 v1 square. So let us write v1 value. Anyhow, we know v1. What is v1 formula? Let me write once. m1 minus m2 into u1 by m1 plus m2 plus 2 m2 u2 by m1 plus m2. So v1 is equals to m1 minus m2. m2, that is u2 at rest. This is going to be 0. u2 0 means this is 0. So what is m1? m1 minus m2 by m1 plus m2 into u1. This is 0, so no need to write. Plus 0. So v1 I got it. I got v1. What is that v1? Velocity of the first particle after the collision. Let me find v2 also. Let me find v2. What is the v2 regular equation? v2 is, our equation is m1 minus m2 means, I think you remember the v2 equation, m2 minus m1 by m1 plus m2. I am writing so many steps. u2 plus 2 m1 u1 by m1 plus m2. Substitute these conditions. u2 0. u2 0 means this term is going to be 0. This term is 0. Got it? If this term 0, this is 0, then what is remaining? 2 m1 u1 by m1 plus m2. So this is v2. I got v1 v2 values. Target is fraction of Ke, fraction of momentum, but I am finding v1 v2 values. Why? Because I am going to use this v1 v2 values in kinetic energies. What is Ke1? Half m1 v1 square. v1 is this. What is KE2? Half m2 v2 square. You can use this v2. So, therefore, KE1 is half m1 v1 square. KE1 half m1. What is v1? v1 is this much. You apply the square for this. So, m1 minus m2 by m1 plus m2 square and u square. See, v1 square. Okay. So, let me write this one. KE1. Let me take half left side. m1 left side, u square left side. U square, this you can take left. What is there in the right side? m1 minus m2 by m1 plus m2 whole square. KE1 by half m1 u square. Half m1 u square. Half m1 u square is what? Half m1 u square is nothing but KE, which is equivalent to m1 minus m2 by m1 plus m2 whole square. This is from 1. What is 1? Half m1 u square is KE. And see, I am getting some kinetic energy ratio. Okay, this ratio we can call it as fraction of kinetic energy retained by m1. Okay, this is the fraction of kinetic energy retained by m1. Okay, fraction of kinetic energy retained by m1. Okay, let me write one more here. And similarly KE2 nothing but what? Half m2 v2 square. Is it visible? KE2 half m2 v2 square. KE2 half m2. What is v2? v2 is this much. v2 square nothing but v2 square. So 2 becomes 4 m1 square u1 square. Okay, what is u1? What is u1? u1 is u. Okay, here u1 is u. u1 is u. u1 is u. So 2 nothing but 4 m1 square. u1 is u. So u square by m1 plus m2 whole square. Got this one? Is it visible this side? Okay. Yeah. KE2. So left side is KE2. Take half to the left. m2 to the left means inside this one. u square you can take to the left side. U square. What is there in the right side? m2 taken left, half taken left, u square taken left. Then 4 m1 square. Sorry, here m2 is there. So no need to take m2. So the space is not sufficient, no problem. So let me write here. Observe my words here. KE2 divided by half taken left. m2, m1 square is there. Take 1 m1 to the left. Take 1 m1 only. 1 m1 means one more m1 is there here only. U square you can take left. U square. Then what is there in the right side? Half is taken left, 1 m1 taken left side. So right side 4, 1 m1, 1 m2. So 4 m1, m2 by m1 plus m2 whole square. What is this half m1 u square? KE. So you are getting KE2 by KE, nothing but ratio, which is equivalent to 4 m1 m2 by m1 plus m2 whole square. And this KE2 by KE1 called as fraction of kinetic energy transferred by m1 to the m2. So I am getting fraction of kinetic energy transferred by m1 to the m2. So this is what? This is the fraction of kinetic energy retained by m1. Retained by m1 formula, m1 minus m2 by m1 plus m2 whole square. Keep this formula in mind, useful to solve some problems. And last one, fraction of kinetic energy transferred by m1 particle to the m2 particle, that is 4m1 m2 by m1 plus m2 whole square. Downside is square is there. So use some simple mathematics and try to remember the formulas. So these are somewhat good today. Okay. So fraction of kinetic energy. In the same manner, you try to find the momentum. First you take this and try to find the momentum. Don't feel as a lengthy. For understanding point of view, I written every steps neatly. So don't feel as a lengthy. I can write direct formulas in a matter of 1 steps I can write. But you try to understand now. That's why I am writing so many steps. See, every derivation also I am writing number of steps. Especially for understanding point of view. I can write in a 1 step. I can speak something in air and I can write something on the board directly 1 step. So that's not good. So at least you maintain these steps and practice it. Definitely you will understand something. Okay, and use these formulas to solve some numericals. Okay, learning concepts is different from applying concepts to the problems. Okay, anyhow concepts are so many we covered. Apply the concepts for problems, otherwise all concepts are useless. So here what I start, how I consider m1 particle moves with a speed u, strikes another particle which is at rest. After the collision, v1, v2 are the velocities and ke1, ke2 are the kinetic energies, p1, p2 are the momentums. Then I written before collision what happened and I calculated v1, v2 values after the collision. Then ke1 I written. If you substitute v1, you will get half m1 something u square. If you take this value left, this is nothing but ke. So this ratio is nothing but fraction of ke retained by m1 and other ratio is fraction of ke transferred by m1 to the m2. In the same way, you try to get momentum p1 by p and p2 by p. Get the momentum. Completed this. Next also some good formulas will come. Yeah, let me rub this. See, in the same manner, you try to find momentum, fraction of momentum retained by m1 and fraction of momentum transferred by m1 to the m2 particle. So follow the same process, try to get momentum. So v1, v2 anyhow it is clear. Now fraction of momentum, let me write directly. P1 by P, fraction of momentum retained by m1, is, so P1 by P, like ke1 by ke, P1 by P, previously I written ke1 by ke, P1 by P. What is P1? P1, M1, V1. P1 is the momentum of the first particle after the collision, M1, V1. P, momentum of the first particle before collision, M1, U. Then substitute V1 value. P1 by P, M1 gets cancelled. What is V1? V1 we got this one, V1. So directly we can write V1 by U value, M1 minus M2. Take this U left, V1 by U value how much? V1 by U value from that equation, V1 by U is M1 plus M2. Otherwise into U by divided by U say. So this is the fraction of momentum retained by M1. M1 minus M2 by M1 plus M2. Similarly, fraction of momentum transferred by M1 to the M2 is, so P2 by P. What is P2? M2 V2. P2 is the momentum of the second particle after the collision. P2 as M2 V2. P is before is what? M1 U. M2 by M1. V2 by U. What is V2 by U? Take this U left side, V2 by U. V2 by U is 2 M1 by M1 plus M2. M1 gets cancelled. Then P2 by P is 2 M1 M2 by M1 plus M2. So use these formulas to solve some problems. Okay, how much I got? Fraction of momentum transferred by M1 to the M2. P2 by P, I got it as 2 M1 M2 by M1 plus M2. See, this is the fraction of momentums and fraction of kinetic energies in case of elastic collision. See here, there is no loss of energy. Okay, there is no loss of kinetic energy, there is no loss of momentum because the collision is perfectly elastic. Why? Because the shape and size of the body does not changes. So there is no loss of energy in case of elastic collision. There is no loss of momentum in case of elastic collision. Means 100%. If any momentum is transferred, 100% of momentum is transferred from one body to the other body. If any kinetic energy is transferred, 100% of kinetic energy will be transferred from one body to the other body. So there is no loss of kinetic energy, there is no loss of momentum in case of head-on elastic collision. Okay, in elastic collision there is no loss of energy. We can find the fraction, but there is no loss. Next one is inelastic. Otherwise, before that, let me solve one or two questions to get some confidence. Some simple problems, let me give in a general. Completed? So let me give one simple problem. So write down shortcut way. A particle of mass m1 strikes another particle of mass m2 which is at rest. After the collision, both particles fly off, move opposite. Okay, both particles move in opposite direction with same speed. Then the ratio of masses, then ratio of masses. So this is also simple question, regular question. This is ratio of the masses, useful for your board exams also. Let me read. Particle of mass m1 that is going to strike another particle of mass m2 that is at rest, which is at rest. After the collision, both particles move apart, move in opposite direction with the same speed. Then what is the ratio of the masses m1 by m2? Okay, they are not asking v1 v2. They are asking m1 m2. Why? Because their m1 m2 are not given. m1 m2 not given. Particle of mass m1 strikes another particle of mass m2. So strikes another particle of mass m2 means, see, this is m1, moves with something u, u1 is equal to u, m2, u2 is 0. Why u2 0? Second particle is at rest. After the collision, first particle move, second particle also move with the same speed but in opposite direction. After the collision, both particles will fly off in opposite direction. Both particles will move opposite to each other with the same speed. So if this one moves with something speed, v1 is equals to minus v, because left side, v2 which is equal to plus v. Got it? If right side, this particle moves with the speed v, this particle move left side with the same speed but left minus, that is right. Okay? Then let us use the conditions here. Okay, let us use. What is our regular formula? We know u1 minus u2 is equals to v2 minus v1. What is u2? 0. u2 is 0. u1 is u, u2 0, v2 is plus v, v2 is plus v. Okay, v2 is plus v. v1 is minus v, minus of this minus, plus v. So what is u? u is something 2v. Okay, keep one equation. u is 2v. Therefore, from law of conservation of linear momentum, okay, you can use v1 v2 formulas, you will get the answer. From law of conservation of linear momentum, m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. What is m1? m1 only. What is u1? u, u2 0, m1 as it is, v1 is minus v, plus m2 v2 v. So m1 u, what is u from the equation 1? 2v. u from equation 1 is 2v. This is if you take v common, minus m1 plus m2. Shall I write m2 minus m1? From equation 1, u written as a v. You can strike v. 2 m1 which is equivalent to m2 minus m1. Take this m1 left. 3 m1 m2. So m1 by m2 which is equivalent to 1:3. If mass ratio is 1:3, then both particles will fly off in opposite direction with same speed. Okay, so regular question and general thing. So mass ratio is how much? 1/3. Otherwise you can use v1 equation, v2 equation, you will get the same answer. Okay, take any one equation, v1 or v2, you will get the same answer. Okay, you try this. Simple question this is. You try the next one. I'll give you. Let me write the questions in shortcut way. Find V1, V2 as shown. Do it fast. The next one, I given some simple thing to get some confidence. I given some simple question. 2 kg mass with a move with 2 meter per second. 1 kg move with 1 meter per second. Then they are asking find V1, V2 after the collision. Means find final velocities of the two particles after the collision. Find V1, V2 after the collision. V1, V2 after the collision. So what is our V1 formula? Take this is M1. And this is U1, this is M2, U2. What is our V1 formula? Remember M1 minus M2. You have to remember this formula. M1 plus M2, U1 plus 2M2 U2 by M1 plus M2. So V1 is equals to M1. How much M1? 2. M2 1 kg. M1 plus M2 3. U1 2. M2 2M2 1, U2 1, 1 plus 2 3. So 2 minus 1, 2 by 3, 2 by 3, 4 by 3 meter per second. Get V2. Do it fast. Easy things these are. What is V2 formula? Quite opposite formula of this one. M2 minus M1. Remember this formula. At least remember V1, we can identify the V2. This is U2, 2, M1, U1 by M1 plus M2, M2 is 1, M1 is 2, U2 1, this is 3, 2, U1 is U1 also 2, yeah, no problem. 3. This is what? Minus 1 by 3 plus 4, 8 by 3. Okay, 8 by 3 minus 1 by 3, 7 by 3 meter per second. Simple questions these are. Okay, take this. So let me write one more small question and I will stop this class now. So let me write the question for the next one. A particle of mass m moving with a speed v. Particle of mass m moving with speed v hits elastically another particle, another stationary particle of mass 2m on a smooth horizontal circular tube smooth horizontal circular tube of radius r. Radius smaller. Then they are asking the time in which the next collision will takes place is equal to the next collision the next collision will take place is equal to, yeah, simple and good question this is. Read the question twice. A particle of mass m moving with speed v hits elastically another stationary particle of mass 2m on a smooth horizontal circular tube of radius r. Then the time in which the next collision will take place. See, there is a horizontal circular tube. See, this is the horizontal circular tube. Okay, on board the diagram is like this only. So, horizontal circular tube. Okay, there is one particle here whose mass is m and moves with a speed something v naught. And at certain distance, one more particle is there. What is this mass? 2m. But this is at rest. This radius is given r. Then see what is this? Is it elastic or inelastic collision? No doubt this is a elastic collision. So if this particle hits the 2m, then what is the velocity of the 2m? V. Just now I given in the last session, I think one particle hits some 4 particles. Okay, then see the velocity will be transferred to this. Here the velocity of this particle becomes v. Then velocity of the particle is v. The time we can write it as time for the next collision is distance travelled. Distance travelled is how much? Same distance travelled, 2 pi r by velocity. So this is the time. Velocity is equals distance by time. Time travelled is distance travelled by the particle of m is 2 pi r. Distance travelled is 2 pi r by velocity. Velocity is v naught. So this is the answer. Direct question actually. 2 pi r by v naught. Why? Because very simple. From here to here, before the collision, this is at rest. Velocity of approach how much? Velocity of approach. Velocity of approach. We know velocity of approach is equal to velocity of separation. One is m, other one is 2m. V naught minus 0. V naught minus 0. 0 minus v naught. So these two velocities are same. So these two velocities are same, that's why 2 pi r by v naught. Okay, 2 pi r by v naught. Use the velocity of approach and velocity of separation concept. One is v naught, other one is 0, v naught. Next separation also, one is 0, other one is v naught, so v naught. So the time in which the next collision takes place is distance travelled by velocity. Distance travelled by velocity is, distance is 2 pi r by velocity is v naught. Okay.